Patty Simpson with Simpson Math. Let's learn about combinatorics. So we're going to answer the question of how many. As we look at probability, we need to know the total number of outcomes that there are in certain experiments. And sometimes even when it comes to the events, we need to know how many different ways we can get those events. So in order for us to be able to do the probability and find the probability, we need to be able to answer that question of how many. So here in counting, we're going to answer that. How many ways? How many groups? How many choices? And there are 3 different techniques that we're going to use to help us answer that question. The first one is called the fundamental counting principle. And in the fundamental counting principle, we'll use this when we have independent events, a certain number of choices for each one of those independent events. And in that case, we'll just multiply the number of choices in each case. So for instance, if we want to know how many different outfits we can wear, and we look at the number of shirts we have, the number of pants we have, and the number of socks we have, shirts, pants, and socks are all independent events as we choose each one of those. And so however many we have of each one will multiply together. Or another example might be if you're taking a multiple choice test and each one of your questions has a certain number of answers to it. And you want to know how many different ways could I fill out this test? Well, each question then is an independent event. And you'd have to look at how many choices there were for each question and just multiply those together to find out how many different ways. So for the fundamental counting principle, each one of our parts is an individual little event. Here, for permutations and for combinations, for both of these, we're going to have a large group of something, and we're going to be choosing from that large group, some of that group, or maybe all the group, but we're going to be choosing from that group. So in both of those cases, we have the same situation, large group choosing some. But in permutations, the order matters. And when we say the order matters, the reason the order matters is because each one of our places that we're choosing for is a place or a position. Like maybe I'm lining you up in line. Well, you know you want to be the line leader. Or maybe you're really keen on turning off the light, so you want to be second in line, so you get to turn off the light. Or maybe you want to hold Miss Simpson's clipboard, and so you want to be third in line. The position there matters where you are. That order matters. So when order matters, or we're arranging something, you know, the pictures on the wall look one way. When we arrange them, it looks one way, but if I switch them around, that's a completely different thing. The order there matters. So those arrangements in places or positions, we'll use permutations. But when the order doesn't matter, then we'll use combinations. So instead of choosing you to get in line, I'm just going to choose you for bonus points. Well, you know, you don't care if you're chosen first or last, as long as you get those bonus points. So when the order doesn't matter, or I'm choosing a group where it's just a group and everybody in it's the same, then we're going to use this combination to help us out. So we're going to use these 3 techniques to help us to answer the question, how many? Math Made Simple is Simpson Math. Thanks for watching.